So hello friends, hope everyone is doing great. So today we are going to talk about some of the questions in geometry related to circle. So before we move to questions, I'll just quickly review some of the basic concepts and formula which we checked in the previous lecture. So first we saw area of circle, which is pi r square. Then we saw circumference of the circle, which is 2 pi r, where r is the radius of circle. Then we saw length of arc. How can we define it? It's theta by 360 into 2 pi r, where theta is the angle inscribed by the arc at center. Then we saw area of sector similarly, which is theta by 360 into pi r square, where r is the radius. And we saw one of the properties which tells us inscribed angle made by the arc at boundary of circle is always half the central angle made by the arc at the center, correct? So now we'll move to the question quickly. So what they have given in the question, they have 3 semicircles here, and Mn is the diameter of this first circle, and they have given the length of Mn, which is x, and they have asked what is the area of the shaded region. So this shaded region, we have to compute the area of that part. So first we'll see, like we have 2 points here, Mn. I'll just draw a point here, point P for our reference. So we have 3 semicircles, right? So how we can compute the area of semicircle? Semicircle's area would be half of the circle, correct? So if my area of circle is pi r square, this area of semicircle would be pi r square by 2. And if I put r is equal to d by 2, which is the diameter of the circle, so what would be the area of circle? It would be pi by 4 into d square. And what would be the area of semicircle? It would be pi by 8 into d square, correct? So here if I have 3 semicircles, I'll just compute the area of this first, considering this point. So area of semicircle will be pi by 8 into d square, correct? So this area of shaded region, what it would be, I'll just take pi by 8 into, I'll just consider this as first circle, this semicircle as second circle, and this one as the third semicircle. So I'll just consider the first area of first semicircle, which would be pi by 8 into mn square. Then area of second semicircle would be pi by 8 into mp square. And area of third semicircle would be pi by 8 into pn square, correct? So I'll just take pi by 8 as a common from this equation. So inside I'll get mn square plus mp square plus pn square, correct? So this is area of my shaded region. So if you see here, here this is a right angle, 90 degrees angle, and we can see here a right angle triangle PMN, correct? So in this right angle triangle we can apply Pythagoras theorem. So if we apply Pythagoras theorem, what it says, the sum of squares of the sides is equal to square of hypotenuse. So if I'll just write it here, so with the Pythagoras theorem, the PM square, which is one of the sides, plus PN square should be equal to MN square, correct? So here I know Mn. What is the Mn value? Mn they have given us it as x. So I'll just put it as x here. So x square. So my value Pn square plus Pn square is x square, correct? So I'll just check it here. This is the same, right? Mp square plus Pn square and Pm square plus Pn square. So I'll just put this x square here. Mn, I know Mn value is x, correct? So Mn I'll put x square and this value is x square. So what will be my final answer? It will be pi by 8 into x square plus x square. So I simplify this, I'll get pi by 4 into x square, correct? So this is my final answer and the area of the shaded region. So now we'll move to the next question. So what they have given, a wheel makes 1000 revolutions to cover a distance of 88 kilometers, and they're asking to find radius of the wheel, correct? So if I'll just draw a wheel here for reference. So if I consider this wheel, and this wheel is going in this direction. So if I consider this point as A, So in one rotation, how much distance it will cover? If it rotates like this in this direction, in one rotation, how much distance it will cover? It will cover distance which is equal to circumference of this circle or wheel, correct? So I can conclude that in one rotation, on one revolution, it covers the length of its circumference. So what we have been given, it has done 1000 revolutions to cover distance of 88 kilometers, correct? So if I have to compute the circumference of the circle, or I can call it distance covered by the wheel in one revolution, I can divide this 88 kilometers by 1000. So kilometers I will just convert it to meters, which will be 88,000 meters upon 1000. So my circumference would be 88 meters, correct? And we know how to compute the circumference of the circle. Circumference of the circle is 2 pi r. So I'll just put circumference here. It's 2 pi r equal to 88, correct? Here pi I'll put it as 22 by 7. Just for simplification, it's 22 by 7 into r equal to 88, correct? So if I solve this, I'll get the answer 88 by 4. It should be 14 meters, correct? So the radius of my circle here, or the radius of the wheel, is 14 meters. So this is my final answer. Let's move to another question. So in the question they have given there are 3 circles, each of radius root 7 centimeter. A triangle is formed by joining the centers of the circles. And they have asked what is the area of the shaded region, right? So in this diagram you can see there are 3 different circles and they have the radius of root 7 centimeters each. And you see centers are joined to form a triangle and they have given shaded area here, 3 shaded areas. They are asked what is the area of the shaded area. So first we will just see angles that here in center. So this is this angle I'll just put as theta 1. Second angle I'll just put as theta 2. Third angle I'll put theta 3. So we know how to compute area of sector. Area of sector is theta by 360 into pi r square. Right? So we'll just consider this as first sector, this is second sector, this is third sector. So let's compute the total area. Total area, how we can compute? Total area is first sector's area theta 1 upon 360. We know the radius of circle pi into root 7 square. What is the area of second sector? It's theta 2 upon 360 into pi into root 7 square. What is the area of third sector? Theta 3 upon 360 into pi into root 7 square. Correct? So let's take this pi into root 7 square common. I will simplify it with pi into 7. Bracket it will be theta 1 plus theta 2 plus theta 3 upon 360. So we can see here this is a triangle, right? Triangle formed by centers of 3 circles. So as we know, the sum of angles of triangle is always 180 degrees. So here theta 1, theta 2 and theta 3, the summation should be 180 degrees. So we'll just replace that with 180 here. So theta 1, theta 2, theta 3. We'll just circulate that. So what will be the final answer? Pi into 7 into 180 by 360. So I put pi as 22 by 7 here. 7 I cancel it. It's 1 by 2. 2 into 11. My final answer would be 11 centimeters square. So this is my final answer and area of the shaded region.